Okay, today we're going to talk about graphing linear inequalities. Linear inequality is an inequality that usually contains two variables. You can think of it just like graphing our linear equations, except instead of an equal sign, we're going to have an inequality sign. A less than, greater than, less than or equal to, or greater than or equal to. A solution to a linear inequality is any ordered pair that satisfies the given inequality. Okay, so if we're going to determine if the ordered pairs are solutions, all you're going to do is plug them in, and if you end up with a true statement, it is a solution. If you end up with a false statement, it's not a solution. So I'm going to plug 2 in for x, 5 in for y, 2 times 2 is 4, 3 times 5 is 15, 4 minus 15 is negative 11. Negative 11 is less than 15. That's a true statement, so it is a solution. Okay, next we're going to plug in negative 1 and negative 7. So I'm going to do 2 times negative 1 minus 3 times negative 7 is less than 15. So I'd have negative 2 plus 21, because of that double negative, is less than 15. 19 is not less than 15, so it's not a solution. Okay? These two are not labeled as you tries, but I would like you to do those as part of your notes after you go through the video, or pause it now and do that as part of your homework check. Okay, so steps to graphing. The first thing you're going to do is write it into slope-intercept form, which hopefully you guys are already really strong at, right? That's our y equals mx plus b. But this time, instead of an equals, we'll have our inequality sign. Okay? Now we're going to use a dotted line if it's a less than or greater than. And I'll tell you why in a second. And you're going to use a solid line if it's an or equal to. The reason for that is the same reason that when you graphed this the other day, you used an open circle on 5 because it did not include 5. The dotted line tells me that the ordered pairs on the line are not solutions. It will not make a true statement, so it's dotted, okay? Likewise, when we had this, we colored it in because it included 5. So we would have a solid line on these inequalities because the ordered pairs on that line would be included in your solution set. Okay, if that doesn't make sense to you, re-listen to that part, come in for questions, we'll go over it the next day, okay? All right, then you've got 2 ways to figure out where to shade. Because inequalities, remember, again, going back to this, all the numbers smaller than 5 would work. So you have an infinite number of solutions. Same thing with these graphs, okay? So we're going to do some shading to show where all the ordered pairs would work. So you could use a test point to determine which side to shade, and we'll get into that in a minute. Usually the origin's a good idea, just because it's easy. The other little hint that I give is if y is less than or equal to, you're going to shade below the line, which kind of makes sense. You think less than, below. And then if y is greater than or equal to, you'll shade above the line. If this makes no sense yet, it will once we start actually graphing, okay? All right. So let's get started on the first one. It's already in slope-intercept, So you're going to graph your first point, your b, like you normally would. So b is -5. And we're going to give it a slope of 1/3. But now I see that it's not or equal to, so I know it's a dotted line. Just like that. On these you have to have nice long lines. Okay, the dotted line means if you picked an ordered pair on here, so for example 0, -5, you would have 0, -5, and you would end up with -5 is greater than -5, which is untrue. Okay, so none of the ordered pairs on this line would work, so it's dotted. Okay, now for the shading, if you use the trick of greater than or less than, it shows y is greater than 1/3 x minus 5, so we're going to shade everything above the line. I picture the line as part of the roof of a house, so if the roof went like this is above the roof, this is above the house. So you're just going to shade it in like that, and it doesn't have to be perfect. To do the test point, I usually pick the origin because it's easier. So I'm going to plug 0, 0 in. 0 is greater than 0 minus 5. Okay, since 0 is greater than -5, I know that 0, 0 has to be in the area that's shaded, so I shade the whole area where the origin is. Okay? Okay, looking at the next one, we're going to graph as normal again. So now my b is -1 with a -2 slope. I would do as many points as possible on these. Okay, now this one's an or equal to, so I'm going to draw a solid line, because if you plug in the ordered pairs on this one, you'll end up with a true statement. So for example, 0, -1, you would have -1 is less than or equal to -1. It is because of the or equal to, okay? So that means any of the ordered pairs on the line would be solutions, which is what makes it a solid line. Okay, now I see it's a less than, so I want to shade below the line. Again, if I picture that as the roof of a house, if I'm underneath the roof, it would be in here. You can pick a test point, so I'm going to pick the origin again. And I'm going to say that 0 is not less than or equal to -1. The origin's here, above it, so I need to shade in the opposite area. Okay, now we're going to take it up just a tiny bit. Number 3 is not given in slope-intercept, so we need to rearrange it by subtracting 5x, just like we've been doing. But the catch here is remembering when you divide by a negative, you have to flip that inequality sign. Okay? So my y-intercept is -6 with a slope of 5/2. So 1, 2, 3, 4, 5, 1, 2. Okay, I see that it's not an or equal to, so I'm going to do a dotted line or a dashed line. Still has arrows. Now to figure out if you shade above or below, use your slope-intercept form of this inequality. So it's a less than. I'm going to shade below the line. If you need your test point, stick with the origin if you want to make it easy. Okay, 0 is not less than -6, so since the origin is here, I need to shade the other area. If your line ever goes through the origin, you would need to pick a different test point, because that won't work. All right. This one again, we're going to solve for y. And divide by your negative. So we're going to flip our inequality sign one more time. -2 is our b. Slope is 1/4. the solid line because it's or equals to. I can see that y is greater than, so I'm going to shade above the line, all this area above the line. If you plug in your tester point, you would have 0 is greater than or equal to -2, which is true. So you're going to shade the whole area in where the origin would be. Any ordered pair on any of these that fall into the shaded area are solutions to the inequality, and that's the real important thing to know here. All right, getting into the you tries, go back and do the last two on the front, and then you're going to graph these. Take a second and write those down. And then you try 3. And you try 4 is a nice challenge, but if you don't overthink it, you'll be fine. Okay? All right, have those done in class, and we'll talk more about what the solutions mean later.